biomedical waste management. This is covered under Ministry of Environment and Forest and Climate Change. After the modification in the 1998 Biomedical Waste Management Rules, it now covers 4 biomedical waste management categories. Environmental Protection Act 1985-86 is the overarching act. First logo is of biomedical waste. In case it's not given in the choice, please remember it also is the logo of all types of infectious waste or biohazard. Second logo is, you have seen outside the CT scan lab and X-ray rooms of your hospital, right? Medical college. So this is a radiation hazard symbol. Now if you look carefully in this radiation hazard symbol, we have got an outer circle, this one, and an inner circle also. Then please remember, inner circle radius is 1.5 r, outer circle radius is 5 r, where what is r? R is the radius of black dot in the center. So this is about radiation hazard symbol that we should know. Now let us look at biomedical waste management categories. Type of waste goes into which bag, what is the final disposal mechanism is asked. I am telling you a shortcut by going in the reverse direction. This is blue category. So which type of waste actually goes into blue category? Blue category waste includes all the metallic implants. So orthopedics, ENT, cardiothoracic vascular surgery, even dentists use a lot of metallic implants. One of the good examples is pacemakers. So pacemakers of the heart are also disposed after using blue category. This category also includes all glassware. And what is the final disposal mechanism of blue bag? Now after subjecting the waste to autoclaving, hydroclaving, microwaving or chemical treatment, it is finally sent for recycling. So please remember, blue bag is subjected to recycling. Then we look at white container. It's not a bag, it's a container. What is the reason that this is made a puncture proof container? Absolutely right. This contains metallic sharps. So sharps waste. So this will include scalpels, surgical blades, scissors, needle part of syringe also. What is the final disposal mechanism of this waste? Now when we look, after subjecting them to autoclaving dry heat, they are sent for destruction shredding and finally they are put to use in iron foundries. Otherwise, landfill or sharp pits also, they could be disposed of. White container. Then this is the final two categories, yellow category and red category. Now when we look at yellow category first, yellow category include majority types of waste. So this include waste like human anatomical waste, placenta after delivery will go into yellow category. amputated fingers, limbs, gallbladder, appendix after appendectomy, any type of animal waste, any type of soiled waste. Soiled waste includes any cotton or cloth material contaminated with pus or blood, bandages, dressings, swabs. These all will go into soiled waste, even gauze pieces. Then we have chemical waste. Along with that, discarded medicines and cytotoxic drugs. So you tell me which medications are logically discarded. These are expired medication. They also go into yellow category. Then microbiological and biotechnological waste. This includes your live attenuated vaccines, sera, toxins, immunoglobulins, all will go into category yellow. Then a new category introduced, bed linen mattresses. And also any type of liquid waste. Now, when we look at yellow category, this waste, what is the final disposal mechanism? What is the final disposal mechanism of yellow category? That is incineration. Except liquid waste, which after chemical treatment is thrown into drain, yellow category is disposed by incineration. Now, finally, we look at red category. Which type of waste are thrown into red category? This include waste like contaminated recyclable waste. So, this would include all your plastic and rubber waste. Plastic part of syringe, Foley's catheter, Ryle's tube, any Euro bag would also be covered under this. Gloves are also going to be covered under red category. So, what is the final disposal mechanism for this particular bag? Now, when we look at red category, after autoclaving, hydroclaving, microwaving, they are subjected to destruction shredding, and finally it is sent for road making. Otherwise, energy or fuel oil recovery also we try to do. Now, please remember friends, generally Euro bag or plastic bag goes into red, but if that Euro or plastic bag contains blood, then it will go into yellow. Now, we look at specific types of methods one by one. This is autoclaving. When we look at autoclaving as a method, then it is steam under pressure with the principle with which it works. Now, it has a temperature of 121 degrees centigrade mostly. Pressure used is 15 psi for a duration of 45 minutes. And when we look at how do you check sufficiency of autoclaving, we use spores of organism Geobacillus stereothermophilus. Now, hydroclaving is also same. It is done hydroclaving at 132 degrees centigrade, steam under pressure. But when we use organism to check sufficiency of hydroclaving, that is Bacillus subtilis. Looking at other methods used in Indian hospitals and medical colleges for disinfection, sterilization, incineration works at a high temperature of 1200 degrees centigrade. So, it has a principle on which it works is high temperature and dry oxidation. Now, generally incineration we can use for any type of waste, but it should never be used for radioactive waste, which should be having C burial. It should not be used for reactive chemical waste. Like X-ray films, we extract the silver first. It should not be used for heavy metal waste, lead, cadmium, mercury. It should not be used for PVC plastic waste. Toxic fumes may lead to angiosarcoma of liver. It should not be used for pressurized waste. Chances of explosion should be there, and it also should never be used for red bag, as the plastic material of red bag contains cadmium. When we look at microwaves, these are 12 nanometer 2450 megahertz waves. These waves lead to sterilization or disinfection by generation of convection currents in heated water molecules. Now, when we look at microwaves, its sufficiency you can check by using the organism Bacillus atrophis. Now, please remember friends, not just microwave sufficiency, dry heat sufficiency also you check by using Bacillus atrophis. Dry heat is done above 185 degrees centigrade. Hot air oven is 160 degrees centigrade. Now, when we look at new methods, then one you should know is, if you are having large volume of toxic biomedical waste, our first priority is to immediately convert it to non-toxic waste. Then we can store it and we can dispose it off slowly on a daily basis. Now, for doing this, what is the method used and what are the chemicals which are used? The method is known as inertization. Now, please be careful in the exam. I am not saying incineration. You have to read carefully. We are making the material inert, and what do we use for inertization is 15% cement and 15% lime. 65% is waste, 5% is water. What is SFT? Screw feed technology. Now, when we look at this new method of biomedical waste management, then it is very similar to what you have seen on construction sites. We have big drums in which we put biomedical waste plus inertization material like cement. Then we start rotating these drums like they do at construction site on trucks, and we start giving heat from below. So, what is its principle? It is a non-burn dry thermal process. What is the advantage we get? It reduces weight by 20 to 25%, and it reduces the volume of biomedical waste tremendously by up to 80 to 85%. This screw feed technology is used for any types of infectious waste and sharps also. But this screw feed technology is strictly contraindicated for radiological waste, cytological waste and pathological waste. Mercury spill. How will you collect the mercury drops? These are collected by using cardboard. If not available, we can use plastic syringe also, and then these mercury drops are put into a plastic cup or bottle of water, sealed and sent to the lab for recycling. Please remember, final disposal mechanism of mercury in India is recycling. We can use sulfur or zinc powder to absorb if any smaller drops are left. Sodium thiosulfate powder could be used for decontaminating the surface also. Blood spills. A unit of blood falls on the floor. Now it is rendered useless for us. But how do we dispose this particular biomedical waste? We use sodium hypochlorite. Sodium hypochlorite, it is recommended that we should use 1% for smaller blood spills and 10% for larger blood spills. HIV infected material also should be pre-treated with sodium hypochlorite. E-waste, electronic waste should be sent for recycling. When we look at TB sputum disposal, then its best method is collect in a paper bag, send it to incineration in the hospital. Otherwise, dry burning at home, 5% cresol, boiling and autoclaving could also be used for TB sputum disposal in our country.